What up, dudes? Let's get this party started. How long is class today? Class will last until from 12:45 till 1, 1:10, 1:20, 1:30, something like that. Um, oh yeah, and then Lucas said, "What about the quiz today?" Yeah, I'm gonna move it. I need to fix it and then move it. I apologize for not fixing it yet. Um, so I'm gonna push it back to sometime, probably in next week or 2 weeks or something like that. But really, it's not teaching you anything new. It's really just kind of like honing in on the skills that you've learned already. And I hope that I hope that rational function section was really interesting. Because I really think that what it's doing is it's teaching you guys a way to think really correctly. All right. So what I want to do is I want to fulfill Sophia's wishes and get through as much of the SAT prep as I can. So I'm not going to go over any old homework. I'm not going to fix any thing in my lecture. I'm just going to go, boom, let's hit SAT. So let's just get started on this. All right, the first thing that I showed you how to do was pick numbers. All right. Sorry, need a. So the first thing I showed you guys how to do was pick numbers, and we got into this whole yeah. Oh man, I forgot. I didn't grab that new SAT book, whatever. I think that I want to get through this chapter, and then I'll go grab the new SAT and see what the SAT is all about as far as the new thing goes. But regardless of whether you're taking the new SAT or the old SAT or whatever, these techniques really help. So the first technique I showed you was pick numbers, and we've seen how that really simplifies our lives. And we had that whole discussion of like, well, how do you know if it works for these numbers? How do you know it's going to work for all the different numbers? You know what I would honestly do? I would honestly pick numbers, solve the problem, get the right answer, circle it, right? And then what I would do is I would check just to make sure the logic goes through. And for that we had that whole situation where like A and B were odd and even and all that kind of stuff. Yeah, you don't need to check all the numbers in the world. A lot of times you really only need to just check two situations. All right. Let's try this one. In 1995 to 1990, the berry production of Bush X increased by 20%. So from 1985 to 1990, berry production increased by 20%. Increase 20%. Got it. And let's see. From 1990 to 1995, berry production increased by 30%. So from 1990 to 95, increase by 30%. We cool? What percent of increase in berry production occurred over the 10-year period of 1985 to 1995? Now, a lot of people will say 50% right off the bat. A lot of people would just say, oh, it's 20% plus 30%. Well, you went up by 20% and then you went up by 30%. Does that make sense? That would be wrong. That would be totally wrong. And one of the reasons why I'm showing you this problem is it still falls under the pick numbers category. The technique I'm going to use for this is pick numbers. But the number I'm going to pick is, when dealing with percentages, it always gets kind of funky. When dealing with percentages, it's always good to choose a number, and the number I would always choose in a percentage is the number 100. So maybe I should choose 100. Oh wait, I got another call. Give me a second, sorry. Hello? The 26th and also the 29th. I'm in class right now, so I can't talk. But okay, perfect. All right, okay, let me back. All right. So when picking numbers, all right, and it's dealing with a percentage, choose the number 100 because 100 works perfectly because a percentage is out of 100. So let's pretend that the berry production in 1985 was 100 berries. Now that's a pretty lame company, right? Like 100 berries, but it doesn't matter. You know what I mean? I can choose it to be any number I want. All right. So from 1995 to 19 or from 1985 to 1995, the berry production would be well increased by 20%. So in 1990, you have how many berries are you producing per year? 120, right? Because you're increasing 100% by 20%, right? That's not uh, that's not craziness at all, right? And in fact, since we chose 100, increasing 100 by 20% is really easy. All you do is add 20, done. Now, changing 120% by a certain percentage, that's not going to be as easy, but you know, at least the first step was easy. Does that make sense? All right, Cameron, since you came late, let me explain the problem to you. In 1985 to 1990, the berry production increased by 20%. Then from 1990 to 1995, the berry production increased by 30%. So, what is the increase from 1985 all the way down to 1995 over the 10 years? And a lot of people would say, oh, it increased by 50%. And I say, no, that's not right. So what technique am I teaching them here is I'm teaching you guys how to choose numbers. Just like how we chose numbers with like, we'll choose an odd number and an even number. And no, it's not 150%. It didn't increase by 150%. Let me explain to you. So what I did was I'm going to choose the number 100. That's the number I'm going to start off with. I'm going to pretend that my berry production was only a measly 100 berries a year or something like that. I can make 100 berries per year. That's a lame company, I know. But I don't care about the company. I care about finding the answer. All right. So you got 100 berries. So from 1985 to 1990, how much berries are you producing in 1990? 120, right? Because you went up by 20%. Doing percentages of 100 is super easy. All right. Now, from 1990 to 1995, you want to go up by 30% of this number. Does that make sense? You want to go up 30% of that number. Exactly. So, what you want to go is 30% more of this number. All right. Do you guys know how to do that? It's pretty easy. I'll ask, what is 12% of it, or what is 10% of this number? Is 12. So what's 30%? Is 36. So I'm going to add 36 more to this number, giving me 156. Are we cool? Nothing complicated or confusing or anything. So, if I started off with 100 berries that I could produce every year in 1985, then by 1995, I'm making 156 berries a year. So, the actual increase of this is not 50%, it's 56%. That is my increase over the 10 years. Does that make sense? And choosing 100 is pretty easy. The reason why it's 56% is because what you're doing is You're increasing it by 20%, and then you're increasing the bigger number by 30%. Does that make sense to you? If I said, well, between the course of 1985 to 1995, the percentage increased by 50%, by 20% and 30% combined, then yes, the increase would be 50%. But in this case where you're taking it in 2 steps, you're taking the 30% of a bigger number than just a straight up 100. Am I making sense here? Anyway, none of this math was really hard at all as long as we chose this number. All right, anyway, another example on how picking numbers will help your brain. It made the math all really easy. All right, hey, do me a favor, you guys. Do me a favor. Go into the classroom. Look for, there's an SAT prep thing that I just opened up for you guys. Look for chapter 13 and open that up. I'm on page, well, it says page 285. All right? That way you guys can see the thing. I won't have to write up the whole the whole problem for you. All right. So, yeah, it's a PDF file. It's chapter 13. Chapter 13, page 285. I'm going to do the problem on the bottom. All right. So, here's what I got. A music club draws 27 patrons. Patrons is basically people. So you have 27 people. 7 more musicians. If there are 7 more musicians than singers in the club, how many patrons are musicians? So 7 more musicians than singers. How many of them are? How many of them are there? And the options they gave us was A, 8, B, 10, C, 14, D, 17, and E is 20. All right. Here's what I would do. You can't pick numbers. That won't help you. But the fact that it's a multiple choice test means that one of these options has to be the answer. Does that make sense? So since one of those options has to be the answer, here's what I can do. I can basically choose one of these and see if it works. And plug that into my equations and see if it works. All right, so the question is asking for, what was it asking for? It's asking for how many of these are musicians, all right? So here's what I would do. When back solving, that's the technique I'm going to teach you here, back solving. When back solving, basically plugging in your answer into the original one and seeing which answer works. Always start with C. Okay? Now, ask me why. What's the point of doing that? Well, okay, fine. Here, I'll tell you why. Because they usually put the answers, the options that they give you in numerical order, from lowest to highest. Got it? Yeah, if the thing is in order from lowest to highest, and I choose the middle, and I start with the middle, then I know that if my answer is too small, then I just go up over here to the next one. But I know that if my answer is too small and I started with the middle, I can automatically cross out A and B if it were too small. So A, B, and C are crossed out. If I started with A and my answer was too small, then I got to go to B and then check my answer. If that's too small, I got to go to C and then check my answer. If that's too small, then I got to go to D. I could have done that in one step by starting with C. Does that make sense? Or if your answer is too big, then you work your way down and you can cross out D and E because those are obviously if this one's too big, then these ones, no chance. There is no chance because this one's already too big. 17 is even bigger than 14. That's guaranteed wrong. Does that make sense? All right, so check this out. If I start off with 14, then I'm saying there's 14 musicians, right? Here's musicians. Here's singers. All right, if I start with 14 musicians, how many singers are there? There's 7. Good. So how many patrons are there? Patrons are, right, 14 plus 7 only gives you 21. That's not big enough. So I'm going to cross out 14. That's not my answer. But guess what? Since I started in the middle, I can cross out 8 and 10. Does that make sense? All right. Then the next one I'm going to do is I'm going to check out 17. So if there's 17 musicians, how many singers are there? Well, you guys are already figuring this out. There's 10. And 10 plus 17 is 27 patrons. Oh, good. That's my answer. We cool? All right. So when... Oh, how did I get 10? Well, it said there's 17 more musicians than singers. So if there's 17... Or there's 7 more musicians than singers. So if there's 17 musicians, then there's obviously 10 singers. All right. But again, starting with the middle, that will help you out. All right, let's try this one. I'm on page 286 in chapter 13, so that way you can read the problem if you don't like my writing down. But let's say if A plus B plus C equals 110, and A equals 4B, and 3A equals 2C, then B equals what? And here's my options. Here's my options. It's 6, 8, 9, 10, and 14. Are we cool? Those are the different multiple choice. All right. So what I could do is I could do the rule of substitution, and I could substitute the heck out of this thing. I can plug in A over here, and I can plug in A over here, or C over here, and then figure something out, and it will all work. And I can do this algebraically. It's a little complicated. It's actually not that hard. It just takes a heck of a long time. But here's what I'm going to do. I'm just going to say, okay, well, let's pretend that B is 9. If B equals 9. Now, why did I choose 9? Or why did I? Because it's in the middle. Good. And if this ends up being too small, then I'm going to go up. And if it ends up being too big, I'm going to go there. But at least I know I can start in the middle. So if B equals 9, then A equals 4 times 9, 27. No, wait, 36, sorry. And C is equal to, let's see, 36 divided by 2 is 18, 18 times 3. Can you guys do me a favor? I'm just not good at math in my head. Plug 36 into there. That would be 36 times 3 divided by 2. What's 36 divided by, or times 3 divided by 2? 65. All right, good. Okay, so C is 65. So if I add A, B, and C up, do I get 110? Oh wait, it's not 65. No, it's not 65. Is it 65? Oh, I wrote the problem wrong. Wait, no. 3A equals 2C. So 3 times 36. 3 times 36 is 108. Oh, this is 54. Yeah, yeah. That's not hard. That wasn't hard math. I only screwed that up because I don't have a calculator with me behind this glass cage. You guys should be the ones checking that. That's just plugging things into your calculator, which is 3 times 36 divided by 2, right? All right, good. All right, so if you add these all up, that becomes 99. All right, so I got a question. I can totally cancel out the C. Which ones? Oh, okay, so you're suggesting that I cross out A and B as well. Good, absolutely. Totally it. We cool? All right. So here's what I'm thinking. Say that we screwed this thing, or say that we're really short on time, and we crossed out A, B, and C, right? Now we need to guess. Is the answer D or is it E? You think it's E. I honestly think it's D. Because look, here's what I would say. We got pretty close to our number using 9. If I move this thing up by 14 to 14, I think that's going to change it way too fast. I think that moving it up just a little bit, this is just my intuition. This is just what I'm thinking, all right? We can check this. I honestly think 10 will do it. I think 14 is going to blow you out of the water. It's going to make your number way bigger than 110, because with B equal to 9, A plus B plus C was 99, and we only need it to be 110. Does that make sense to you? So I'll tell you what I'm going to do is I'm going to let you plug in 10 in for B, and you can figure it out and tell me which one's the right answer. All right, fine. We'll do it. Or you guys want to do it on your own, and then I'll just wait. All right, fine, I'll do it. B is 10, C or A is 40. Is it 40? Yeah. A is 40, and so 40 times 3 is 120 divided by 2, that's 60. So 60 plus 40 plus 10 is 110. Good. But honestly, if I were like really screwed for time and I really didn't like have the time to solve this, I would have just crossed out these 3 and then guessed this one and then move on. You can take the time to check it, but I'm just saying, like, do you understand my logic here? So what I'm doing is I'm trying to show you how I take tests. I'll take a look at it and just be like, well, I'll start with this one and I'll see if I need to go up. And if I need to go up, then I'm thinking that I'm only going to go up that much. Now, if I had the time, I totally would solve it. I totally would plug it in, and it didn't take me more than 10 seconds. But if I didn't have the time at all and I needed to guess, I would have gone with D. And maybe that's just intuition. Maybe that's just after a while you just get good at this stuff. All right, let's see. We finished talking about back solving using back solving. All right, here we go. Phones and all right, strategies for guessing. Oh, this one's a really good one. A really tough one because it deals with ratios, and people always screw up ratios. I'm on page 287. We're doing a problem about celebrities and agents. All right. The ratio of celebrities to agents in a certain room is 13 to 11. So celebrities to agents is 13 to 11. We cool with that? If there are 429 celebrities in the room, how many agents are there? So if 429 celebs, how many agents? All right, You can set up a ratio. It's not really that hard. Yeah, this isn't hard, but let me show you a thought process that I have. 143, 363, 433, 507. Don't solve it yet. I know you can. All right. There are three answers on here that are just completely stupid. Which ones are those? There are three of them, right? I would say C, D, and E are totally dumb. Gone, gone, and gone. Why? Yep, Bradley, you called it. It's D and E, and even C is correct, or wrong. Right. Because there's more celebrities than there's agents. So if there's 433, which is bigger than 429, that doesn't represent a 13 to 11 ratio. Does that make sense? So any number that's bigger than 429 is out. It's just dumb. I'm not even going to spend my brain cells on it. I'm just going to cross it out. Right. And Sophia is guessing by her intuition that A is way too small. Now, A would be good if it were something like a 12 to like a 3 ratio, right? Or, I'm sorry, I can reduce that to become 4 to 1. Because then 429 would be about 4 times bigger than 143, right? If the ratio were originally like 4 to 1, something like that, or something close to that, then I could dig that maybe A would be the correct answer. But it's not. It's 13 to 11. So it's almost like, since these numbers are so close to each other, then there's going to be almost as many celebrities as there are agents, but the agents is going to be a little less. So B is the only realistic choice. Does that make sense? All right, cool. There, that's all I wanted to show you with that style of problem. It's eliminating the dumb answers. Okay? Now, if you can eliminate one, all right. Now, I used to have this technique, or this saying that, like, all right, since the SAT will take off a point for, all right, since the SAT will take off 1 point for every problem you get wrong, don't guess on the SATs. But apparently you're telling me that the SATs have changed their rules now and they don't take off points, which means you're allowed to guess, but save guessing to the very end, all right? Don't just guess on every problem. That'd be stupid. Save guessing to the very end. And the best thing you can do is at least eliminate choices. Because now, if you automatically eliminate that without even using your brain, then at least you have a 50-50 shot. And then you look at this one and just be like, well, that thing's way too small. Well, boom, you have a 100% shot now. Done. All right, we cool? It used to be that the SATs would take off a quarter of a point for every question you get wrong. But nowadays, I think what it is the SATs will just not give you a point if you get it wrong. Which doesn't necessarily mean that's a good thing. All right, let's try this one. On hard questions late in the set. Okay. All right, cool. So if I have a number x and it's increased by 30%, this is problem number, or on page 288 from this little pamphlet that I have, the chapter 13. And then the result is decreased by 20%. All right? Then decreased by 20%. All right? What would the final result of the change be? And then here's what your options are. A, x increases by 10%. B, x increases by 6%. C, x increases by 4%. D, x decreases by 5%. And E, x decreases by 10%. All right. So I'll read to you the problem, all right? So that we, all right. A number x is increased by 30%, and then the result is decreased by 20%. What is the final result of these changes? X is increased by 10%, x is increased by 6%, x is increased by 4%, x is decreased by 5%, or x is decreased by 10%. All right. Here's what I would say, all right? D and E are definitely wrong. I'm just going to cross those out. Do you guys need me to elaborate on that? Or, all right, okay. D and E completely wrong, right? Because if it goes up by 30% and down by 20%, how is that going to end up being a bigger negative? Like, how does that end up going to be decreasing overall? That doesn't make sense to me. Okay? All right. Now, here's the thing I want to show you, all right? The other thing I want to show you is this. This problem appeared late in the SATs. Which means, now I told you guys the technique, right? The SATs has problems from easier to smaller. Or easier to harder, I'm sorry. And then the ACT just put the randomize button. They just mixed it up. They don't care. So since this problem appeared later in the SATs, I'm thinking that it's going to be harder, which means that my initial gut reaction to something like this would be increased by 10% is probably going to be wrong. I bet you that's not the right answer. And I can tell you it's not the right answer. And what is the right answer? Well, the right answer is actually B. Oh, wait, no, I screwed that up. The right answer is C. Sorry. Yeah. Okay, well, we can... All right, what would I do? To do this problem, what I would probably do is plug in a value for x. And, oh, there we go, Cameron. You learned something. Yeah, let's choose a number for x. Let's choose the number x equals 100. Then an increase of x equals 100 is 130. Right? But then I got to take 20% of 130, which is equal to 26. Right? So I got to subtract 26 from 130, which is 104. So the actual increase is 4%. Good. I'm glad you remember that technique to say, well, let's choose a number for x then and see what the actual thing is. Yeah, absolutely. That's exactly what you're going to do. That would be how you solve that. But actually, the point of me showing you this problem is not how to solve it. It's for me to show you, hey, let's look at this. All right? What I'm showing you is this one is in the section where it's probably going to be a harder problem because it's maybe the higher numbers in like it's problem like 80 on the SATs, which means it's probably going to be harder. So what I'm saying is your gut reaction, the one that they're obviously leading you towards, they're saying, hey, which one's the answer, is wrong. And Mr. Dalday does that to you all the time. Right? And then you guys would choose A, and then I would say something stupid like, you guys are absolutely wrong. Because I'm a punk like that, and I enjoy making you guys suffer and squirm. Yeah. Don't get fooled when Mr. Dalday does it to you. And don't get fooled when these idiots who make SAT tests do it to you. All right? By the way, the guys who make SAT tests aren't idiots. They're way smarter than me. But I'm just saying. They're going to throw things like this in there to screw with you. Just like I do all the time. Now, I do it so I can teach you. They do it because they want to mess with you. They want you to have a bad score. I do it because I don't ever want you to forget your mistake. Yes, absolutely, Lucas. I would say don't choose your gut reaction choice on the later problems. That's not true for the earlier problems on the SATs. Now, for the ACTs, this trick is completely moot, right? Because the ACTs all over the place. It could be the first problem is the hardest problem in the test, and the last problem is the easiest problem. I don't know. I don't know why they do it, but all right. Yeah, you say that you need to write all these strategies down. They're all written here. In fact, all these examples I'm doing are straight out of this book. All right, so read the book. All right, let's see. Let's do this one. I'm going to do one more and then we're done. Yeah, this is chapter 13 from the SAT section in your class. I just opened it up. All right, so what this is saying is, in the figure above, what is the length of B to C? So this is 45 degrees. And this is 30 degrees. All right, and then this is 2. And here's A, B, and C. All right, you're going to like this test. You're going to like this trick, okay? What are your options? The options are square root of 2, which is about 1.4, or 1.41. It's also 2. It's also 2 square root 2, or 4, or E is 4 times 2 root 2. All right. So, the best thing to do, yeah, this isn't a right triangle. The best thing to do is to, well, here, I'll show you, okay? Check this out. You're gonna trip out on this one. This one you're gonna like. By the way, what is 2 times the square root of 2? That'd be like 2.82. And then what is 4 times the square root of 2? I don't have a calculator. You guys figure it out for me. Just 4 times the square root of 2. What is it? 5.64? Okay, 5.64. All right. Now, when a figure, and you're going to learn this in geometry, or you've taken geometry, right? Bradley's saying geometry problems are the worst. All right, you're going to love this technique. In geometry problems, you took geometry problems, they always told you, don't trust the figure. Don't trust the picture. Did they tell you that? They told me that. They said, the picture might be off. Okay. And on the SAT and the ACT, I originally thought that that was true. Don't ever trust the picture. But I noticed that on the SAT and the ACT, they draw the picture accurately. If they tell you not to trust the picture, they will actually write the words, figure is not drawn to scale on the bottom of this. But unless they write that, you can assume that it is drawn to scale. Okay? So check this out. Check this out. This is going to blow your mind. Here's what I would do with this problem. At least to give me that initial gut, like, this is how I'm going to eliminate all my answers. I'm going to take my pencil. I'm going to use it as a ruler. You guys are tripping out. You guys are like, what? Yes, I'm going to take my pencil. I'm going to use it as a ruler. See that? This is 2 feet long, or 2 whatever long, because it says 2 right there. Is that 2? Nope, it's longer than 2. So it's not 2. Nor is it 1.141. It could be 3. It could be 4. It could be twice as long. Got it? But it definitely can't be 5.5. That's wrong too. I know. You guys are wigging out right now. You guys, I love this one. This is one of my favorites. Right? You take your pencil, you put it down, and just be like, all right, that's 2. Then that's definitely not 2. It's longer than 2. Now, obviously, my figure that I drew up in here is not drawn to scale, but when you actually look at the problem, it's drawn to scale. You know what I mean? So it's definitely not 2, and it's definitely not smaller than 2, and it's definitely not almost 6. Right? Because that would be 3 pens long. That's way too long. So what are your choices? It's C or D. All right. Now, at this point, I would guess. If I were totally lost in how to solve this, hey, what's up? Give me a second. I'm going to be right out there. If I were totally lost in how to solve this, I would just guess. But let me show you how to officially solve this. Okay? Well, let's see. How do I officially solve it? I don't have time. My physics kids are over here already. So, hopefully, the answer was C, by the way. All right. And you don't even need to use your pencil. You can just take your scratch paper and rip it up, and you can actually make a ruler. What I would do is I would say, well, if this is A to B, then I'm going to fold this in half. And this is exactly twice A to B, right here. See? Yeah. There's stupid tricks you can do. And they're not stupid. They're actually really intelligent and really, really helpful. Anyway, I hope that you like those. I am, let's see, almost done with chapter 13. There's a few more techniques I want to show you. Oh, no, actually, I'm done with chapter 13. The only thing I need to show you guys is grid-ins and how to do those. But my goal is to maybe spend next week on chapter 16, and then I'm going to go backwards and do chapter 14. I previewed for you chapter 14 already. All right, cool. I'll talk to you later. I got to go. Okay, bye.